Welcome to the Inquisitive Minds podcast. This podcast is all about searching for answers to questions oftentimes unexplained or unexplored. We want to engage with new and sometimes old theories, psychology, or philosophy from a research based perspective. Hello, and welcome to the third episode of the Inquisitive Minds podcast. I'm Peter, and I'm joined by my good friend John. How are you doing today, John?
Not bad. How are you?
I'm doing pretty good. So, this podcast, we dive deep into a range of different subjects, but we do them one at a time. So, most of the time, we are diving into something that is in philosophy or psychology or is on the cutting edge of technology. So, our first episode was all about critical thinking, and to me, that was the philosophy. The second one was about attention and social media. That was more psychology. This episode, we're diving straight into the idea of terraforming Mars. This is something that's on the very precipice of technology nowadays and is often talked about as one of the craziest, most adventurous things the human population will ever try to do. So, John, how are you feeling about this topic, and what are your initial thoughts?
I was excited going into this topic because it's just a very inspiring topic, like the exploration of space and even having like maybe potentially another home down the line. So it was exciting to start researching.
Totally. So, I think I want to give a good introduction to what Mars is currently. Mars is known as the red planet, and I'm going to walk us through the potentially three stages. So the red planet, and then from there we go to blue planet and then green planet as a form of terraforming. But what is terraforming? John, you want to tell us how that works?
So terraforming, not to be confused with colonizing, terraforming is making the planet have Earth-like environment. So running water, so you can eventually have crops and all those things.
Yeah.
So it's going to be done by modifying like the atmosphere, the temperature, the surface, topography, the ecology. There's a lot that goes into it.
Yeah.
And with colonizing, it's sort of just settling and making like a permanent residence essentially. It's not so much kind of recreating the whole atmosphere. So I think there's a big difference there between just going to Mars and setting up like some places to live and to actually making it so you can actually walk around and breathe.
Yeah. So when when you say life, you specifically mean human life. Terraforming, the scientists have defined it as specific for human life because right now on Mars, we're not sure if there's some sort of organic um, like microbes living on Mars that could be considered life. And I think that's a big ethical question we should talk about after. But terraforming is specific to humans, making it have like have making it a living conditions for humans. So
Hmm.
so the Mars as we know it right now, big huge red planet. It's about half the diameter of Earth, which means a lot of things change. The mass is another huge part. So the mass is about the mass of Earth is about 900% larger than that of Mars. So a lot of things change when you're on Mars, and the biggest thing that we're going to have to overcome is the gravity and dealing with the gravity. It's significantly less. So Mars is about 71% less dense than Earth, and that is directly correlated with how much gravity you're getting. Um, some things about Mars that do make it a good planet to want to terraform when we're considering planets nearby in our solar system, because the other option is of course Venus, and Venus is closer to the sun than Earth, whereas Mars is further from the sun. So the issue with Venus is it's 900 degrees. It's 900 degrees Celsius. Nobody's doing anything on Venus for a very long time. Um, so Mars is a lot colder. Mars right now has an average temperature of negative 63 degrees. It's completely frozen. Everything is frozen. Mars also has a north and south pole similar to Earth. This is good for us because in the idea of terraforming, we want to be able to release the water that's located at the poles. And on top of the water currently on Mars is frozen carbon dioxide, which is also helpful for our oxygen, which we'll explain later. But we want to be able to heat up the poles so that we can eventually release all the water and the carbon dioxide that's in there. Um, another positive for terraforming Mars is that its axes, which is similar, which is the angle at which the planet sits, is very similar to Earth's. So the tilt of the axis of Mars is 25%, and I believe Earth's is around 27%. So seasons are very similar on Mars. But the difference is their seasons are twice as long, as well as their year. Their year is about twice as long. So Mars takes about double the amount of time to rotate around the sun compared to Earth. Um,
We do have the almost the same length of day though,
yeah, this is another thing. I think it's around 2%. The the day on Mars is 2% longer than the day on Earth.
longer.
Yeah. So, with all that being said, we have some definite difficulties to overcome when terraforming Mars, but we have a lot of benefits. And one of the biggest benefits that I didn't mention was that scientists believe Mars was a planet that had Earth or that had life, that had Earth, that had life. It was a planet that was teeming with all sorts of different life. It had water, it had an atmosphere. We're not sure what the atmosphere was made of, but over billions and billions of years, it slowly lost all those things. Um, mainly due, I've heard that it had
the,
volcanoes that stopped erupting, and there was
yeah, the core is sort of not being molten anymore.
yeah. So molten
So
the
it lost its magnetic field.
mhm.
So then the atmosphere gradually blew away.
Yeah. So the magnetic field that we have on Earth is due to the molten core of our Earth. So that means that the metal within the core of our Earth is hot enough to retain its liquid state. It stays as a liquid. And as it moves with the Earth, it creates a magnetic field around Earth. And this protects us greatly from a lot of radiation coming from the sun. On Mars, that used to be a thing billions of years ago, but it's slowly over time losing its atmosphere. It lost heat, and when you lose heat, the metal slowly becomes a solid. And when Mars is moving, there's no movement of the metal. It's all in a solid state, stationary. Prevents a magnetic field, which prevents radiation from being removed from the surface. So a lot of difficulties, but also a lot of kind of positive things about Mars. One, it had life before. It's got similar days. It's got a similar axes. Um, a lot of really hopeful things for us.
Yeah, it's right on the cusp of the Goldilocks zone.
Yeah.
And there's like the temperature, since the atmosphere is so thin. It's one of the things I saw as temperature was so fascinating. So if you were to stand on the surface of Mars on the equator at noon, it'd be spring at your feet and winter at your head.
So it's the difference in temperature there.
Yeah, like wild, because it's the atmosphere is so thin. By the time it's up there, it's literally pretty much just gone.
Yeah, and that's another thing that is a difficulty for the terraforming process is that the gravity of you wouldn't think this, but the gravity of Earth is actually keeping the atmosphere in place. It's holding all those air molecules around its surface and keeping it as we know our atmosphere now in its different phases down to Earth. Whereas on Mars, the gravity is losing the atmosphere. If for all the CO2 that we try to burn and add to Mars's atmosphere, we're going to be losing a lot more, which makes it very difficult to hold an atmosphere and to terraform.
Yeah, it makes terraforming like X amount of times harder.
Yeah. So let's get into it. The first thing we want to do as terraformers, and there's multiple theories of what to do, and we'll run through them. But the first thing we want to do is get to the blue planet stage. The blue planet stage means we've got water, we've got an atmosphere. The atmosphere is definitely not habitable. It's mostly CO2, which would, of course, be deadly for us. Um, but it's beginning to transform. There's we're taking root. So one of the first theories is we need to add heat. Adding heat provides melting of the poles, like I said, which releases a lot of carbon dioxide, which starts to create our atmosphere. So early on, the question was, can we just use materials on Mars and just use carbon dioxide to create a big enough atmosphere? Is there enough carbon dioxide in the soil or carbon based minerals in the soil that we can burn into carbon dioxide to create an atmosphere? Unfortunately, a study was done recently and it was published in Nature and essentially said all of the carbon material within the soil and within the poles is only going to increase the atmosphere, like the pressure of the atmosphere, by 4%. It is not going to do it. We need a different way. We need to be able to do something different. So there's been a lot of floated. Sorry, go ahead.
So what are all the possible sources that the CO2 could come from on Mars?
Okay, so we've got the poles, which is what I talked about, but it's all frozen right now as carbon dioxide in a solid form. And then there's the regolith. Regolith? It's essentially the
Yeah.
crust, the initial crust of Mars. So if we were to somehow send a mission there, maybe it's just a robot or a group of robots, or it's a human Mars excavation mission, and they started drilling, and as they were drilling, they were burning all of the carbon that they could find in the ground for about 10 meters deep, I think, approximately. That's where all the carbon material is, because further down than that, we don't know what's really going on. We predicted the molten core has hardened because it's got no magnetosphere, but we don't really know what's going on beneath the regolith of 10, approximately 10 meters. It varies on the surface
Hmm.
when you get to different areas. But yeah, that's where all the carbon's coming from. And it's not enough. Very sad.
Sad.
So we're not giving up. The next thing we could possibly do for heat, there's a theory floated for heat that I don't really like, and I'll get your opinion on this. And it's essentially uh, it's a huge reflective surface for the sun. So essentially, they want to float into orbit around Mars, this huge mirror to reflect heat at the poles and just on the surface, essentially to to just heat up the whole planet.
Hmm.
This, I don't know. It doesn't seem.
So how does this solve the lack of CO2?
So this idea was floated before the CO2 was found to not be enough. So this was kind of
Gotcha.
like a.
This is to kickstart the initial heating process.
That's right. And it seems like a lot of money to do something that could be done easier, or like it's like a lot of money and a lot of resources put into something that once it's up there and it's done its job, we should probably take it down because it'll burn us alive. I don't know. So that was one theory. Another theory, which I am more inclined to like, but it doesn't work if you have humans there, is diverting comets from the outer ring of our solar system to hit Mars. The cons for this are we're kind of destroying the surface of Mars. This is like total, like we kill the dinosaurs like 1,200 times. It's going to be devastating for the surface, and we don't really know what's going to be left over. But the pros, well, the other con is that we could potentially miss Mars and hit Earth. Not good. So the pros are it introduces a lot of oxygen, water, and nitrogen, which are the things we need to the surface. It also could potentially bring extremophiles that we've never seen before. Um, it would increase the temperature, it would melt the poles, and it would add more organic material that could be carbon based to add to the atmosphere.
From what I read on like essentially importing volatiles is how like they would redirect it to go into Mars's orbit and then they would get it in from there a lot slower than just like ramming it home after one after another.
Oh, okay.
So they were coming up ways to having a lot slower of an impact rather than just bombardment, right?
Hey, I mean,
So I thought that was sort of fascinating. Now I don't know how much control they actually have, but it definitely like the whole point is to get enough greenhouse gas on in the atmosphere to have the runaway gas effect,
mhm,
and so that begins the positive feedback loop. So once it starts trapping more and more heat up, everything else starts to melt more,
mhm,
which produces more gas in the atmosphere, which traps even more heat, and it's that constant process of heating, and trapping.
right.
And you need to, I think what I read is you need to raise it sort of 6 degrees on your own to kind of start this runaway effect.
Mhm,
But as soon as you start reading about how there's a limit of CO2 on the planet itself, that's when you sort of have to start adding in your own greenhouse effects,
right.
with the redirecting the comets being sort of the first
Mhm.
idea.
Yeah, so the comets idea I like, and especially with you mentioning the ways for us to control the comets coming in and kind of keeping the destruction of Mars to a minimum. That's an idea I can get behind. The problem is how many comets, how much time, how do we get to the outer ring of our solar system to redirect them? Like
Mhm.
if we're getting to Mars, um, already like initially getting to Mars is a huge undertaking, a huge task, but also somehow getting comets like we're talking like years and years and years, like centuries in the future, for us to have the technology to be able to do that kind of thing. Which, again, we're all like this whole discussion is kind of hypothetical. But if we wanted to do it tomorrow, I think that the other option is 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 like super greenhouse gases. So super greenhouse gases are essentially gases like carbon tetrafluoride and uh, dicarbon quattrafluoride, stuff like that. So essentially, and sulfur fluoride gases that have like 1,000 times the heat retention of CO2. So essentially, if we are able to either import or make it on the surface of Mars using the material within the core to create gases that are fluoride and sulfur based gases that can retain a ton more heat than just carbon dioxide, then we should be able to achieve the runaway greenhouse gas effect that you explained earlier much sooner, um, than with the comets. I think the comets are a good idea if we have the technology, but I think it's easier for us to use super greenhouse gases, which by the way are still not something that we can just manufacture. I don't think we have a specific means of doing that yet. But it seems closer in the future than the comets thing. What do you think?
Yeah, it's sort of like you begin to colonize it first, and once you have enough of like a base and kind of structures being built, then you can start mining and manufacturing all this CFCs, and it's it, it's very like unlikely that you go there without sort of setting up a base first, right? There
Yeah.
was one alternative to this is sending all these greenhouse gases by rockets.
Okay.
It's not the nuking idea, but it's having rockets with all these greenhouse gases. So when they hit the surface, it blows up, and rather than the explosion being the heating, it's just filling the environment with all these gases.
Yeah, that's an interesting one. I think, yeah, to go back to your nukes example, I think it was Elon Musk floated the idea of just nuking the poles on Mars, and everyone was like, we've got enough radiation to deal with, and also it's not going
Yeah.
to do that much. So the super greenhouse gases, CFCs, as you call them, are essentially the biggest. way of doing this, and bringing rockets seems like a good idea. It's just they would have to be huge rockets. We're talking about a planet, right? So being able to just send rockets, we would need like a huge fleet of them, or we would need a way to
Well, the
send a
it's
machine that
it's
produces them
it's more
continuously.
of like a steady stream of them. So every so often you're sending another one that hits, another one that hits, another one that hits.
Right.
So it's something that can kind of be done without having to colonize it, and it's something that you don't have to. It's not a one huge big investment. It's just one after another, like spaced out.
Hmm.
Boom, boom, boom. So I mean, it doesn't seem like that bad of a. I just don't know how many you need, right? That
Yeah.
could be the big issue. Is like say you need like 1,000, and it's sort of spread out like every month. That's still quite a while.
I fear that,
But I mean,
knowing human beings, I fear that if we have a steady stream of rockets, like this would have to take a century or something, right? Like this is not happening overnight. This is not happening over the span of a year if we send a rocket every month. So
yeah,
what I'm thinking, what I'm scared of is that if at some point there's a change in administration or somebody
yes,
and somebody's like, why are we sending these rockets? This costs us billions of dollars every month to the friggin' Mars. Cut that program, you know? And then it gets cut
yeah,
and then it's stopped, right? And it's cynical to think that way if we had a perfect scientific world that we live in and we were able to do that, maybe it would be better and easier to do. I
mhm,
I think the if we're talking like hypotheticals, I think the best way, in my opinion, would be send a robot manned fleet with a power plant or several power plants that could land on Mars and generate these kind of super greenhouse
yeah,
gases independently without humans going to start the
mhm,
process and then let them pump with material from Mars, which again sounds like fantasy because we don't know what's on Mars, but that would be my idea.
yeah. Another sort of one I saw was like a mining methane rich Titan. So Titan has a lot of some greenhouse gases, especially being methane, and and then transporting it back to Mars.
Hmm.
But again, like that's quite the travel time,
Right.
and the same issue that I forgot to bring up earlier with kind of the ammonia and with methane is it's I'm pretty sure they're less dense than CO2,
Right.
so they actually dissipate quicker.
Yeah.
So you would need to pump them in way faster than CO2.
Hmm. Yeah, so don't forget during this whole conversation we're losing atmosphere on Mars every day because of the weight of Mars and the solar, they call it solar winds, are stripping the atmosphere from Mars. So we need dense gas particles that hold heat well. We need This is going to take a lot of research.
And that have long lifetimes.
Hmm.
So like methane only lasts for maybe 4 or 5. I'm just throwing out numbers here, but it's not as long.
Right. A CO2, which is a fairly stable molecule.
Yeah.
Yeah. So
Well,
the
maybe that's the good thing again with the CFCs is they're like way stronger of a CO than CO2, and they have fairly long life cycles too.
Yeah, they're fairly stable, people have been trying to find good CFCs. Johnny, what does CFC stand for again?
Chlorofluorocarbons.
Right. So with all these gases, we need to be able to make sure that they're all sticking around, producing heat. All right.
And with them having like short lifetimes and leading back to the CFCs, the chlorofluorocarbons, I saw a number that was how much CFCs we would have to kind of create to start it,
Uh,
and it was 39 million tons. Which, to put this into perspective, Earth, well, us, we create from 19, I think 72 to 92, we created about a third of that on Earth. So we would
Wow.
need about 3 times that we made in that 20 years to start this process.
Right. And that's with us producing. with a whole population of individuals, right? So this is crazy. But like we said, the terraforming process would take hundreds of years, centuries. So I think,
Well, yeah, this is just to get it to the blue stage.
right.
We're not even at the green stage.
Yeah. We're not even living yet.
Yeah, so like just to put the first part into perspective, it was almost kind of demoralizing the more I researched because I was getting so like I always thought like kind of Mars is really exciting and exploring it and colonizing it. And I honestly thought like I would see a lot more in my lifetime, but sort of seeing how far away we're from even just to get water going on Mars, it was like we're not going to see this in our lifetime
Yeah, I was listening.
unless technology just goes on
Tear.
a tear. I just don't see it.
The-
Like I mean, it's always on a tear, but
but it's geared for profit. But there's another discussion. I think I think yeah, what you're saying is correct. And I when I was doing research, I was finding a lot of people who were talking and doing speeches that were kind of selfish, in my opinion. They were like, "Our generation, our lifetime, we're going to see people on Mars." And I was thinking to myself, well, if we want to do this terraforming thing, we shouldn't be doing that. We shouldn't be sending people. We should be sending, unless they're going and coming back um, to pick up, to just get information, to just do some minor drilling. We should be only be sending automated things to try to collect data and build a plan to terraform. Unless we want to go with the colonization idea, which I think we'll get to after. Okay, so let's say we do complete the blue planet stage. What are we left with? We're left with an atmosphere. We're left with heat. We got about the same temperatures on Earth, and we have oceans now. It's not really oceans. It's if you just count all the water on Mars, you have about a bunch of lakes and rivers, but nothing that's really like a full atmosphere, or sorry, a full ocean, which means it might be tricky creating a normal water cycle like we have here on Earth, such as normal weather patterns with water going into the atmosphere and raining and so on and so forth. We're not sure how that would play out on Mars because we're not sure if the water there is enough to
yeah, I guess we're sort of just assuming once we have the atmosphere similar to Earth's,
mhm.
that it would sort of just kind of kickstart the hydrosphere, and we would sort of get that cycle going.
Yeah,
So it's I think it's almost something we kind of assuming that if it's like Earth, it'll do the same sort of process.
right. I think figuring out a way to transport water, like tons and tons of water, could be difficult considering the fact that we kind of have a water shortage here on Earth. So if we melt enough of the water on Mars and it ends up not being enough, I think we have a huge problem on our hands. But
And
let's say we
it's very mountainous too, right? Like you have to like to get to somewhere else on Mars, and it's not like a pipeline just gonna go straight across. Like
mhm.
they have the largest mountain in the whole solar system. Like there's no getting around that thing. Like
Well, let's hope by the time we have the technology to get there, we can just get around it, or we can divert a
just
comet
go
right
right
into it.
through it.
So let's say we do have what I was talking about, the blue planet. Now we have to get to green planet. Green planet Mars is a nitrogen, oxygen rich atmosphere. It's us walking out with nothing on and breathing in the air and living. And with that in mind, we have a plant life growth. We have all sorts of potential foods we can harvest and all sorts of agriculture, all the stuff. So this is the green planet. How do we get there from the blue planet? Well, the main idea is again millions of years, hundreds of years, uh,
Yeah.
with the introduction of cyanobacteria or thermophiles or extremophiles. So these are microbes that have been specifically selected to live in these extreme conditions. So remember, in the blue planet, the atmosphere is pretty much 95% carbon dioxide. If we end up pumping in the CFCs or the super greenhouse gases, those are usually pretty stable, non-reactive. So they like the the plant life or the microbes won't really be able to interact with them much. So we're mainly gearing our specific microbes to carbon-based fuel, and also hoping that they produce nitrogen and oxygen as a byproduct to the growth.
Yeah, so like this will kind of inspire a whole new kind of bioengineering
Yeah.
in plants that survive not only in very heavy carbon dioxide atmospheres, but also in the Martian soil too,
Hmm.
which is quite different than ours.
Yeah, I was reading of
And
yeah.
oh,
Sorry.
sorry, and also kind of while trying to have them be very efficient at photosynthesis too, right? Because you want to make the oxygen. Like, sure, if they want to, if they're thriving in the soil and in the atmosphere, but they're not actually making the byproduct of like a really efficient oxygen, then almost no point
Right.
for the terraforming process.
Yeah, this is where I think geneticists and microbiologists and microbiology geneticists get really excited because they're using CRISPR and they're splicing in genes, and they're trying to make this perfect microorganism to send to Mars. And maybe they have bunch of them, bunch of different types that all have different jobs that they're doing. So the main the main problem though is time, right? If we want to take this from a blue planet to a green planet, we need these microbes given her every day, all day for hundreds of years.
Yeah.
Yeah.
So at our current state in technology, I saw a number. It was a very rough number, but assuming like we have all the plants that are starting to propagate and thrive, it'll take around 900 years for the atmosphere to have enough oxygen for us to be able to breathe.
Yeah. So
900.
so just just eat your veggies and stay alive. Um, yeah, it's kind of crazy. It's one of those things that I, I think will be like such an accomplishment if we ever get around to it. But besides this
Mhm.
idea of adding these microbes, did you find anything else for changing from blue planet to green planet? Anything else that was kind of interesting?
The the only other one I saw was a very like almost like it almost seemed kind of far-fetched, right? Because it was almost it's based out of science fiction.
Hmm.
So the Genesis device from Star Trek.
Okay.
So essentially, I know I think you know what it is.
Yeah,
So like
here's what I know about it is
okay,
they wanted to reproduce a whole planet, and then Spock died. Spock died. Oh man. So they sent Spock's body to this planet, and then they shot this device which is called the Genesis device onto the planet, and it essentially just makes the planet habitable. It's like it's the
just
magic bullet.
instant terraform.
Yeah. And then Spock came back to life. Spoilers. Spock came back to life. Sorry.
So it's based off of that. Like it pretty much explode like it you throw it, it explodes and all this DNA just goes everywhere. And that DNA kind of goes into the surface and starts making all the plants and next minute life blows up, yada yada yada. So it's essentially that. So it's like it's like scientists like find a planet, so like say Mars, and they start researching it. They figure out all the temperature, the soil, the atmosphere, yada yada yada, and then they just do mad research to make this DNA, and then they send fleets of robots with this DNA,
Okay.
and they go around the surface of the planet, depositing it all over. So the capsules are kind of like these things that kind of open and they germinate, they latch, they kind of they create seeds and spores, so they kind of like
Okay, yeah.
uh, pollinate themselves and then they're scattered all over because it's robots, so they can work wonders and put it everywhere.
Sure. So
So now there's this DNA all over the planet,
hmm?
and they're reproducing, pollinating, winds blowing them around, yada yada yada. And then and now everything works as the old-fashioned way of evolution. So you got to wait about like a million years, give or take a million or so, and boom, your planet is terraformed.
Well, if you know what, I do like a good hands-off approach. You know, I like when I can
so
set it and forget it. That's what I like in my
so
planetary revolutions.
you go around, you start looking around all the different planets. You're like, okay, this one, this one, this one, and you just start sending them all out there, or whatever ones are potentially habitable.
You just start shooting them
And
off like
yeah,
guns at a like t-shirts out of a cannon.
yeah,
That's awesome. Um, in if that was a thing that was possible, it would be awesome. It doesn't seem it doesn't seem to be in the near future. It doesn't seem to be in the
he
far future
he
either. I don't
he
know.
says it's within 100 to 150 years
We'll be able
in
to do
terms
that.
of technology research. Yeah, there's like a whole like scientific study and stuff on it. Like he goes through, like it's not just like like some random article on the internet. Like it's like quite the journal. Like
Okay.
it was over my head on half of it, so I just kind of got the gist of it
Okay.
and put my spin on it.
That's fun. That's really fun. The okay, so the other thing that we have to worry about past the green planet is living on Mars. And living on Mars comes with its own set of difficulties if we have perfect environment. So the first and biggest thing in my opinion is the radiation from the sun and the cosmic rays. This sort of radiation stuff, I don't think I'm really going to be able to understand or explain to you. All you need to know is that when radiation comes into the planet and it hits you, it could potentially mutate your genetic code, which could cause cancer and kill you or heart disease. It's real bad. So what's saving us on Earth, like we talked about earlier, is the magnetic sphere. So how do we recreate that on Mars? So I saw one theory. The only theory I saw was create an artificial magnetic sphere. Essentially, it's like a huge satellite, and we send it out over Mars, and it has its own magnetic deflector essentially, and it just rotates around Mars and keeps us safe. That was like the only thing I really saw besides somehow getting to Mars, figuring out what's wrong with the core, and then changing the core. But right now we don't know how or if that's possible.
And sort of relating that back to Earth, if you ever see like the northern lights, that's essentially what is going on with the magnetic field and the solar rays.
Yeah. So
So with Mars, there's nothing stopping it like that. So you'd just be bombarded.
mhm. So that also makes it very difficult for I think the plant life to grow, and um, like we can get from microbes to a clean atmosphere, but it's probably tough for us to do anything about plant life.
Yeah, because when you think of like the lack of a magnetic field, you kind of think like the main concern would be the atmosphere loss.
Mhm.
But that's not even the main concern. Like it would take like 100 to 1,000 years for for the atmosphere that we're building now for it to kind of dissipate. Like we have a long time
Mhm.
if we start this kind of melting process in the greenhouse effect that like it's so minimal it's not even a concern, that the main concern would be the solar winds and the radiation.
Yeah, definitely. So after that, let's say we figure this out. We build a big old space station above Mars. It's got its own magnetic radiation field. It protects us. And the next thing is once we get there, we're living on Mars. We have to deal with a much lower gravity. And dealing with a much lower gravity, you can ask astronauts like Chris Hadfield and a bunch of others. I mean, they lived in zero G. It's a bit different, but you lose a lot of muscle mass, you lose bone density, and you're less healthy. Our whole evolution for millions of years has built us to live on this planet with this gravity. So if we move to that planet with that gravity being about, it's probably around half or less, we'd have a huge, we'd have a lot of health problems. And I think a lot of them would be un, unpredictable, right?
Yeah, and you'd have to, I think I saw you'd have to exercise almost 4 hours a day to kind of negate the muscle loss and bone loss.
Right. It would be
That's
easier. It would be easier to exercise, but I mean, my jogs would be considerably easier. But yeah, I wouldn't want to do it for 4 hours.
yeah.
Right. So that's another thing.
Storms are another one.
Right. Okay.
You can get these like they're called like dust devils, and they're these massive storms. And have you ever seen the size of Mount Everest? That's the size of these storms. The storms are as high as Mount Everest. It's wild. They can blow in, but the funny thing about it is the atmosphere is so thin that they do no damage. They're like a breeze. They'd be coming at like 200, 300 kilometers an hour, and it would be like you would hardly feel it.
Huh.
But but the thing is this dust and the sand, it kind of contributes to why Mars looks so red anyways, because it's so much sand that you see.
Right.
That it would blanket everything,
Hmm.
and the dust would be it would take like a month to 3 months for the dust to settle.
Hmm.
So say you're like colonizing Mars, and your all your energy is kind of all solar energy. If a big storm rolls in and the dust takes months to settle, that's a big problem.
Yeah. I hoping this is why I found it so hard for us to colonize first, terraform later, because hoping that during the terraforming process, with the water coming out, we can reduce this huge amounts of sand and potentially negate negate these huge storms. Um, but yeah, if we were to just send human beings there early, and we haven't even talked at all about power generation. How are we creating power? Well, the biggest thing would be if we're burning the soil, we can use that to turn turbines and create power. But mainly, everybody thinks solar power. Well, if we're using solar power to create our CFCs with our generators, and we have one of these huge storms, well, shut it down for 6 months because
Yeah.
we need a fleet of robots to just get their squeegees out and clean off the
Ye-
panels.
well, it's not even just cleaning that; it's still up in the air. They'd have to somehow blow it out of the air.
Right.
But one kind of like very futuristic technology would be these satellites up in the atmosphere, up in the not the atmosphere, but in
the
the gravitational.
right.
Forgetting the word, but
Yeah, the gravitational pull of Mars.
yeah, like it's in the orbit
Circulation
of
orbit.
the
Yeah, orbit's the word.
and they would be just like these massive solar panels. So it would be just getting like it would be just bypassing all that,
Hmm.
and it would just be the solar energy way up in the sky,
Hmm.
and then it would be just kind of beamed down to them.
Right. We'd have to have what Tesla wanted to build, which was a way of transporting energy without some sort of physical connection. Right.
Yeah.
Hmm.
Yeah, I'm pretty sure that's not really that huge. Like that's something that will probably be figured out not that far away, but sort of.
But we just get all of Earth's extension cords, and
Oh yeah,
we
yeah.
just run it
And
up
with,
there. Ah, that should be easy enough. I like that idea. So yeah, um, that's another issue. Getting back to other issues, we had our cosmic radiation, we had our gravity. Um, I think I think that's about it for issues once we've got everything completely terraformed. So
yeah, I think that's
yeah,
the gist of
those are the
concerns.
main issues, and then we're probably going to have to we'll probably run into issues that are just unpredictable with health, with regards to human health. And I think it would be really interesting. I heard some scientists talking in a video. They explained if we're there for hundreds of years on Mars, we're still human beings, but they would evolve and change, and their whole physiology would be different. So you would see a human from Earth, and they would be average height, average build, and you'd see a human from Mars, and they'd be much taller and have a whole
Slender,
different look to them, and you'd be like, ah, that's a Martian, that's an Earthian, or
yeah.
whatever, a Terran, I guess.
And there's like a whole like kind of book series on like on this what's a called again, but they have like the Martians, the Belters, and the Earth guys. I read the first book.
Is this the Caves of Steel? Is that what you're talking
No, the Expanse series.
about? Oh, okay.
It's like they have like Earth. I mean, they have Mars as like a terraformed, I guess, as a place to live or whatever.
Hmm.
And there's the pretty much the like two planets and then the belt they
Hmm.
call it, I guess, is whatever. And
And Earth,
so like there's actually like sort of like politics and stuff between that and stuff. So like that would even kind of be into play too
for sure.
once you start noticing the different appearance and stuff, right?
Yeah, totally. And and then we have to think about politics and building of societies, rules, laws, governance, all this stuff. But that I think we should avoid talking about. The other
Yeah,
thing I really wanted to talk about was I kept during the research I kept running into this ethical question like I explained earlier. If there's already life on Mars, if we get there and we do some soil sampling and we see microorganisms and life there, what do we do? Sometimes some scientists say stop everything. We're interfering with life. We can't do this. This is a travesty if we come in, we start wiping everything out, and we essentially take life and destroy it for our own means. That's one theology, that one psychology, one thought process. The other one is there's three. I think the other one is why don't we nurture this life that we found, create more optimal uh, environment for it, let it grow and let it have its own planet, but maybe supercharge its evolution and like see what happens. And then the third thing is screw it, we're going in there. This is ours now, America. We're taking this, and we just take over the whole place. Like so,
yeah.
how do you feel about that? If we hit life on
Well,
Mars?
if yeah, that's the whole thing, right? If
Hmm.
I'm not a huge fan of number one. It just I don't know. It just seems like okay, as life, let's just abandon everything, all our efforts, pack it up. This was kind of a waste of time. But if anything, the research and stuff we've been doing, it's telling us the opposite, that Mars used to have life and now it doesn't. So like if we found some sort of life, it almost seems like it's on its last legs.
So you're like put it
So
out of its misery.
no, just in the sense, no, putting out of his misery would pretty much be leaving it alone.
Right. Okay.
So it would be like almost like a two or a three, maybe even a mix. Like
Hmm.
nurture it, wall. Like maybe we'll take this section, you can have your section over there,
Right.
and we'll start maybe changing the conditions better for us over here or something. I don't know. Like
Okay. So like make little national parks and just leave, right?
no, I don't know. I think the more I think about it, the more I'm actually leaning to number three, and
Yeah.
just like we just go over there and just make it ours. Like
Hmm.
clearly, like that life there isn't going to fight us back.
Yeah, I agree with you because as somebody who's kind of a scientist by nature, I like the idea of understanding new things. I like the idea of finding a whole new different organism we've never seen before that survives on Mars, but then learning what we need to know, bringing samples over here, but then still going forward with our expanse and
Yeah.
taking over Mars. So, with that in mind, I think the other big thing I wanted to talk about was colonizing first and biodomes as an answer. So, do you have anything do you want to say about previous things before we move on to this subject?
Well, it's just one of the questions that I saw kind of brought up quite a bit was almost like why are we terraforming Mars? Why are we colonizing Mars? Why are we going to Mars when we haven't solved all the problems on Earth?
Right.
There we haven't even figured out global warming. We have this and that. So like what? The solution is just to go to a new planet and start over. Let's try again. Let's ruin that planet. Like I, I saw it kind of brought up a lot, and I was wondering what you kind of thought about it.
Yeah, I had a couple trains of thought on this one because yeah, I also ran into it too. And I think there's an argument to be made to do something for the sake of doing it, which is why are we not terraforming Mars? You can't really prove the negative, but it's like why are we not terraforming Mars if we could? Wouldn't it be the most brilliant thing human beings have ever done? So the problem
But
is
what
money,
if it costs a lot
yeah,
of money that could
time,
be spent? Yeah.
right. So my my I guess answer to that is can't we walk and chew gum at the same time? Can't we simultaneously fix Earth while terraforming Mars? That's why I think it's selfish for some scientists nowadays to say we're going to Mars in my lifetime. No, we're not. Like we've got issues here. But if we figure out our issues here in the next century, century and a half, then we start building towards terraforming Mars while also saving Earth. The other thing that I was thinking, and people will make this argument, is well, Mars is what's saving us because right now we're destroying Earth. We're very good at it. We're
Hmm.
very good at heating Earth. That's why we're not going to Venus. It's too hot. We're going to Mars. We can heat that up. We're good at heating things. So we're good at this greenhouse gas effect. That was the other thing. So yeah, I think I lean towards the we can walk and chew gum. We can figure this out. We can figure Mars out. And when we do figure Mars out, it'll be amazing. And it's like the first step to taking over like the rest of the solar system slash galaxy slash universe.
I saw one argument. I think it was from Neil deGrasse Tyson. That was kind of interesting. So he was kind of answering this question, and he goes, "So we terraform Mars, and if we can terraform Mars, we'll have this technology and the engineering, like trying to like geographical engineering, that we'll be able to like kind of re-terraform Earth back again once we've ruined it so badly."
Oh,
So I thought that was kind of
ah,
interesting. That we'll have such good technology and have learned so much that we can go back and fix Earth kind of
right.
backwards, reverse engineering Earth back to where it was
Yeah. In a
before.
thousand years, they're gonna look down and be like, guys, we could. That's in the Goldilocks zone. We could probably fix that guy up.
Yeah, what?
What happened to that Terran?
We'll
What
all
was
be
that?
on we'll be on Mars and be like, man, this we're looking at this planet. It looks like it used to have life.
Yeah.
It used to have all these. Look at these, all these riverbeds and
Yeah. Wow. That was a cool planet. Yeah, that's what I think about that question. And it's a good one, and it's a tough one. But
yeah,
yeah, that.
just like it's because you saw it kind of a lot with the space program, not even with Mars, but like with the
With
moon
the
and
moon.
stuff after all the space race and everything got canceled. It's like, why are we spending all this money
Hmm.
when we can't even solve our own country's problems, or
Hmm.
like yada yada yada, like the taxpayers' money, yada yada yada,
Right.
right? Because it's government programs.
Yeah. That the other. Just as a side note, the reason we're not terraforming Mars is that or sorry, the reason we're not terraforming the moon is because it's way too small. The gravity's way too low. It doesn't have. You can never make an atmosphere there. So sorry, but yes, you're right.
And
Funding is a huge issue, and right now we're all interested in SpaceX, which is Elon Musk's company, which is nothing to do with the government. It's all privately run businesses. Is this going to turn into the little board game Terraforming Mars, where you own a business and you're competing against other businesses to terraform Mars the quickest? Like, is that what's going to happen, or is it going to be a concern, like a cohesive effort from all of human mankind?
that's a good question, right? Because it's a good thing that private companies are getting involved, because that's way more money to for the space. But again, that's more politics when it comes to getting on the planet.
Yeah.
So like,
Hmm.
say like what is SpaceX, like say we're like talking colonization in the early phases or whatever, and like what SpaceX has their own little colony, and then NASA has their own little colony, Boeing has their own little colony,
Right. Yeah.
Jeff Bezos has his own little
He's just
area,
got a
and
little
like,
island.
and is it going to be like early Earth where people are like taking other
and
colonies over? Like, are we
tribal
gonna?
warfare and
Yeah, like
oh man. So
because with the International Space Station, it's kind of like almost funded by everybody. Everyone kind of gets sort of a chance to send someone up there,
right.
and
This is why the International Space Station is still afloat, is because it's run by the different countries that send their. It's all government run, right? You have
yeah.
so the question would be: are governments going to step in and make the companies that want to go um, have some sort of like repercussions if like are they going to make it so
But
all the companies that are investing are working together? I think
but how is it like their jurisdiction to comment on what goes on in space or on
I have
Mars,
no
right?
clue. Yeah,
It's
nobody has any clue how this is all going to work.
mhm. I think there's so many politics gonna be going forward. It's gonna be kind of crazy.
Yeah. So last thing I wanted to talk about biodomes. Instead of terraforming the whole planet, what if we just built huge biodomes that were the size of cities, like big cities, and instead of having to deal with all this blue planet, green planet thing, we just plop it in there. We had some sort of containment. We brought our own supply of oxygen and nitrogen. We built a small barrier that's got a magnetic sphere around it to protect us from radiation, and we lived in this biosphere on Mars. What do you think?
So like the movie Martian, but on like another whole nother scale
Yeah,
in terms
exactly.
of like cities.
Yeah,
I th-
and it's
I
just
just
a
can't see that being like long term because the gravity, right?
hmm
Like you would have to create some sort of system that when you're in these domes that the gravity is stronger or something, right?
well, there is a there. I saw one model which was really cool. Was a huge biodome, and in the middle was all the farming. So they had changed the regolith of Mars, and all of it was farming and wildlife. And then on the outside was the city, and it was on an angle, and it was rotating around the biosphere in such a speed that it would create uh, gravity similar to that of Earth. So essentially, it reproduced Earth's gravity on
Mm.
Mars in a biosphere, and that was where the city was. Everybody lived there, kind of thing. That was a pretty cool idea.
I assume there would be some sort of kind of ex like trips outside of the dome and stuff. I could see a lot of people kind of getting almost like a claustrophobic kind of feel.
Yeah, I'd assume they'd have scientists and researchers in gear going outside the dome um,
Like
to set up
I just can't see
whatever.
sort of like almost like a long term living. Like
hmm
people spend their whole lives there. Like
hmm
it would just kind of they would feel I don't know. I just feel like there'd be a lot of psychological effects to it. Sort of like I've heard of like super long term space travel where they're sending like these massive ships like with generations on it. So like say they're in space for like 200 years going somewhere like
Yeah,
where they're having kids and their kids are to pass over on their jobs to have kids to
yeah,
keep having so this ship can keep going to its destination or
right.
whatever.
And that's essentially
It
Mars,
almost seemed like that with Mars
right?
in terms of its colonies.
Yeah. Well, the other thing, just as a side note, I'm not sure if we mentioned this, it takes approximately 6 to 8 months to get from Earth to Mars using common means, using means, not common, but means that we have nowadays, the technology that we have nowadays.
Just a car.
Just a car, just get in your car, drive your Tesla. Um, yeah. So you're right. It would be crazy psychological, but what if we did have those generations growing up on Mars and that's just how they lived and what they knew, right? It would be interesting.
Yeah.
So I think I think the biodomes is an interesting short-term solution while we potentially like let's say we build the biomes, we have enough to survive, we can somehow have energy when we have those big Martian red storms and we have protection from radiation, we have food, we have generations of people living on Mars now. Then they go forth and they terraform it like as they're living essentially they build the
Yeah,
radio
like their
the
full-time
yeah
jobs, yeah.
yeah
Another kind of rather than the big biodomes, would be kind of underground
Right.
because they had so many volcanoes and stuff. There's lots of these underground caverns. I think they're kind of there's a word for them, but there's already like these pre-dug kind of run like stuff under the planet.
Okay.
So essentially, almost going down there to start colonizing it
Hmm.
in order just to get out of the radiation and stuff. But again, I can't see that being a long term
Yeah.
unless you sort of just dig out the entire planet and you're just underground. You're like underground people.
You're mole people. I don't know. I find that one tougher to picture because you need oxygen, and unless you're always in a spacesuit, you need to you need to be able to prevent oxygen leaks from your cavern, essentially.
Yeah, it would just be like instead of the big domes, I guess it'd just be underground.
Right.
I don't know.
Yeah, I could.
They just wouldn't
I
be as durable, right? Because you
yeah.
would be out of the storms.
Hmm.
Maybe it'd be a lot lighter. Like you again, you could be have oxygen and stuff inside, but they just be a lot like almost more cheaply built
Right.
because you would be out of everything.
Hmm. So I think with all of that in mind, I don't think we're going to be terraforming Mars for the next 1,000 years. And I mean a full terraforming. I don't mean
Yeah,
making biospheres. I don't mean living underground. I mean terraforming. A
yeah.
1,000 years. What would you think?
It's just hard to put like a number on it because say if technology was still and stagnant and not going crazy or whatever,
Yeah.
I would agree with the 1,000 years. But like with the way technology is kind of increasing, I'm sure something is going to be crazy and it's going to like make the process a lot quicker.
Yeah. I just worry about the politics. I worry about people interfering with it. I, w-
Yeah, that's
I
true.
would, those are my worries. And also the process just being longer than we ever anticipated. The
Hmm.
scale of it being enormous.
Yeah, I definitely don't expect it in our lifetime, which is kind of
Sad.
a little sad. But the more I kind of think about it, the more it sort of makes sense.
Hmm.
Like, the more I kind of are educated about it,
Hmm.
it's like, yeah, it's definitely like. Whereas when I didn't know much about it, it was like, oh, terraforming, that'd be kind of cool, right? Like we played the board game and yada yada yada.
Yeah.
I'd be like, oh yeah, it'd be kind of cool. Like it'd be like quite the flight or whatever. Like
Hmm.
I don't know, it would be kind of I
Yeah.
don't know if I would
I'm
do
I'm
it,
saving
right?
up for
But
my trip, you know.
yeah,
Yeah.
again, that's another thing is tourism, space tourism.
Hmm.
Like,
Uh,
but anyways,
yeah.
but yeah, it's yeah, not no more Mars inspiration for me.
Yeah. I think we've closed the book on this for our lifetime, but not for humankind. I think I'm still
Yeah.
hopeful. So with that, I've said everything I want to say. Do you have anything else? Any final words?
No, I think that's everything.
Cool.
I think we covered everything.
Thanks again for listening to Inquisitive Minds podcast, and we'll catch you next time when we hopefully give you something to think about.